Oh, hello again. This is Sample Physics here again. Just as a quick another clip to show you basically how conservation of momentum can be applied. Now, if you have a gun of mass 2,000 kilograms, the mass of the 2,000 kilogram gun is going to fire a shell of mass 20 kg at a velocity of 120 meters per second. Now, an important thing to note is that when you apply conservation of momentum, you need to think about which direction you are going to show as being positive. Now, we're going to show things going towards the right being positive. So by applying the conservation of momentum will give you the mass of the gun times by the recoil velocity. When I mean recoil velocity, that means when you fire the gun and the shell and the mass of and the shell actually fires out, the gun will actually move backwards, then the mass will move forwards. And this is really action and reaction, Newton's third law here. So when you apply this principle here, we have in fact the mass of the gun itself will actually move backwards. As a result, what happens is that we actually look at them times in the mass of the gun with the recoil velocity of the gun is equal to the mass of the shell times by the velocity of the shell. This will actually give you a calculation here where we have 2,000 times by V is actually then going to be equal to minus 20 kilogram times by 120 meters per second, where V is equal to minus 1.2 meters per second. Now, just to show you my version of how you calculate this, we can look at here a calculation where we have, obviously in more diagrammatic form, we have the gun and also the bullet, the mass, the shell, and we can see from here that as the bullet is fired forwards, we are looking at the gun actually firing backwards. As a result, when you apply conservation momentum, we can see from here that we can do 2,000 times by minus V is equal to 20, which is the mass of the bullet, times by 120. And when we apply the calculation, we get the answer, which is V equals minus 1.2 meters per second. Now, minus 1.2 meters per second shows you that the mass of the gun is going to be moving in the opposite direction to the positive velocity of the bullet, the shell. This is enough. This is for sample physics, and next time I will basically move on to looking at impact forces.